Hi everyone, this is S. Om Prakash. Today I am discussing about the de-broglie wavelength. Before going to the topic, let us clear about the backstory of the de-broglie wavelength. Non-particle behavior of matter was first proposed in 1923 by Louis de Broglie, a French physicist. In his PhD thesis, he proposed that particles also have a wave-like properties, although he did not have the ability to test his hypothesis at the time. He derived an equation to prove it's using Einstein famous mass energy and relation and Planck equation. And next, introduction of the de Broglie hypothesis wavelength. Let us know about the de Broglie hypothesis. In quantum mechanics, any objects can behave both like wave particle duality at the submicroscopic level. And next, wave particle duality. An object can act as a both wave and particle at the same time. This phenomenon is called wave particle duality. So, the ability would have energy packets, momentum can be passed to another object wavelength, frequency and amplitude, etc. By using photoelectric effect and component effect, we can easily describe about the wave particle duality. And Einstein postulate a beam of light can be treated as a stream of particles like photons with zero rest mass. Each photon has energy. It is defined as E of a P is equals to HF is equals to HC by lambda, where H is a constant times a constant here. H is equals to, and its value is 6.63 into 10 to the power of minus 34 Js. F lambda c are the frequency, wavelength and velocity of light in vacuum respectively. Light intensity is proportional to photon flux. It is the number of photons passing through unit area per second. And next, from special theory of relative is E square is equals to mc square whole to the power of 2 plus mc whole to the power of square. Consequently, particle with zero rest mass, example like photon, has momentum p given by p is equals to E by c is equals to hf by c is equals to h by lambda. And next, photoelectric effect. When light of a particular frequency it's on a metal plate in a vacuum, it emits charged particles, which is shown to be electrons. Actual result, maximum kinetic energy of ejected electrons is independent of intensity but dependent on V. For V is less than V naught, that implies for frequencies below a cutoff frequency, number of electrons are emitted. There is no time lag. However, rate of ejection of electrons depends on light intensity. The maximum of kinetic energy of an emitted electrons is then K maximum is equals to HV minus W. And next, summary of photon properties. Relation between particle and wave properties of light. Energy and frequency E is equals to hv. And also have relation between momentum and wavelength. Relativistic formula relating energy and momentum, that is E square is equals to p square c square plus m square c per 4. For light, E is equals to pc and c is equals to lambda v. And here also commonly write this as E is equals to h uh, and p is equals to hk, and wave vector k is equals to 2 pi by lambda. And next, Compton effect. Compton measured intensity of scattered X-rays for solid target as function of wavelength for different angles, and here the angles are here. For this result is a peak in scattered radiation shift to longer wavelength than source amount depends on mu but, no, but not on the target material. And next is Compton scattering. Here these about Compton scattering, incoming photon and scattering photon. Uh, and next, conservation of energy, conservation of momentum. Here are the formulas for these Compton scattering. And next, Compton scattering. Note that all the angles, there is also an unshifted peak. Here the angles are here. This comes from a collision between the X-ray, photon, and the nucleus of the atom. And next, uh, let us see the applications. Although it is difficult to draw a line separating wave particle duality from the rest of the quantum mechanics, it is nevertheless possible to list off some applications of basic idea. Wave particle duality is exploited in electrons microscopy, where the small wavelengths associated with the electrons can be used to view objects much smaller than what is visible using visible light. Similarly, neutron diffraction uses neutrons with a wavelength of about zero point 0.1 nanometers, the typical spacing of atoms in a solids, to determine the structure of solids. Photons are now able to show this dual nature, which may lead to new ways of examining and recording this behavior. And next, the conclusion for the de-broglie wavelength is, from the discussion we can come to a decision that a particle can exhibit wave particle duality, and de-broglie has given the relation which is E is equals to hv and p is equals to h by lambda. But it has some limit. A central concept of quantum mechanics is duality addresses the inadequacy of conventional concepts like particle and wave to meaningfully describe the behavior of quantum objects, since it can't explain the Heisenberg's uncertainty. And thank you.